Hello everyone. Today we're going to look at the basic operations with complex numbers in rectangular form. So first is addition and subtraction. All you have to do is remember that you can only combine like terms, and in this case, like terms mean real parts with real parts and imaginary parts with imaginary parts. So 3 minus 2j plus 1 plus 4j, I'll get rid of the parentheses because they're not really doing anything. And then I'll combine like terms. So I have my real parts, my 3 and my 1, and then I have my imaginary parts, my negative 2j and 4j. So I end up with 4, the 3 plus 1, plus 2j, the negative 2j plus 4j. Remember, you always want your answers in rectangular form, a plus bj, so the real part plus the imaginary part. If it's subtraction, we just have to remember that we need to distribute that negative sign across the second complex number. So it becomes the 5 plus 2j minus 3 plus j, because we have that double negative. And then again, we'll combine our real parts, and we'll combine our imaginary parts. And we end up with 2 plus 3j. Multiplication. So what we do here is just FOIL like we would with a binomial times a binomial. So 2 plus 3j times 1 minus j. We're going to do the first, the outer, the inner, and the last. And that will give us the 2 minus 2j plus 3j minus 3j squared. We have to remember that j squared is negative 1. So we'll simplify that, and this term becomes plus 3. And then we will combine, again, our real parts, which is the 2 and the 3, and our imaginary parts, the negative 2j plus 3j. And we end up with 5 plus j. If I have a complex number being squared, remember that just means 2 minus 5j times 2 minus 5j. And again, we'll FOIL it. So first, outer, inner, last. That will give us 4 minus 10j plus 25j squared. Again, j squared is negative 1. So that plus 25j squared becomes minus 25. I'll combine that with the other real part of the 4. And then my two middle terms are my imaginary, and I'll combine those guys together. We end up with negative 21 minus 20j. What happens if I take a complex number, a plus bj, and then I multiply it by its conjugate? So remember before, a conjugate means I'm just going to change the sign of the imaginary part. So this is a number times its conjugate. I'm going to FOIL it. So I have a squared, I kind of did this backwards, minus abj plus abj minus bj squared. These two imaginary parts are going to end up canceling each other out. And again, j squared is negative 1. So if I simplify all of that, I get a squared plus b squared. The important part to note here is that this is a non-negative real number, right? A squared is a real number being squared, so it's non-negative. The same thing with b squared. Remember, there's no i's here, there's no j's here, sorry. It's a real number plus a real number. Those real numbers are both non-negative. So assuming a and b, neither of them are zeros, then a squared is positive and b squared is positive, and I'm left with a real positive number. We're going to use that when we talk about division. So I have c plus dj over a plus bj. When I want to simplify a complex number divided by a complex number, I don't want to have an imaginary part in my denominator. Okay, we've talked about it before. If you go back to radicals, we would rationalize the denominator. We always want our denominator to be a positive integer. So I'm going to multiply the top and the bottom by the conjugate of the denominator. So notice if I multiply it by something over something, that's just 1. So I'm not changing the value. I'm just changing the way that it looks. And we just learned in the division that a plus bj times a minus bj is a real number. And assuming a and b are integers, then it's a real integer. And again, it's also positive, right? It's a squared plus b squared. A positive number plus a positive number, assuming they're not 0. So that's what we're going to do for these problems. So 2 minus j times, divided by, negative 1 plus 2j. So I'm going to multiply top and bottom by the conjugate, again, of the bottom. So again, we're going to change the sign of the imaginary part. So negative 1 minus 2j divided by negative 1 minus 2j. So the top is going to be FOILed. The bottom is going to be a squared plus b squared. So again, remember, b is the imaginary part. It's the coefficient of j. It is a real number. So we end up with 1 plus 4. So our denominator will be the very nice real number of 5. And then we look at the numerator. So when I FOIL it, I'll distribute the 2. So negative 2 minus 4j. Distribute the negative j. So plus j plus 2j squared. My middle two terms become negative 3j. My plus 2j squared becomes a negative 2. So my numerator is going to be negative 4 minus 3j. And again, my denominator is 5. So negative 4 minus 3j over 5. The next one we have is 1 plus j over 1 minus j. So then we're going to multiply top and bottom by the conjugate of the bottom, so 1 plus j. If I distribute the 1 across the numerator, I have 1 plus j. Distribute the j, I have j plus j squared. The middle two terms is 2j. J squared is minus 1. So my numerator is 2j. My denominator is a squared plus b squared is 1 plus 1 is 2. So my denominator is 2. And then, of course, we should simplify this. That's just j. So 1 plus j divided by 1 minus j is j. For the next one, negative 2 plus 3j over 3 plus j. Multiply top and bottom by 3 minus j. So if I FOIL the top, I'll have negative 6 plus 2j plus 9j minus 3j squared. My two middle terms become 11j. My minus 3j squared becomes a plus 3, because again, j squared is negative 1. So my numerator becomes negative 3 plus 11j. My denominator is a squared plus b squared. So my denominator is 10. So I have negative 3 plus 11j over 10. I can't simplify that any further, so it just is what it is. So let's do a little bit more with all the operations. So 8 plus 4j plus 2 minus 6j. So again, I don't need any of those parentheses, and I'm just going to combine like terms. So 8 plus 2 will give me 10. 4j minus 6j will give me a negative 2j. For my second set, I have to remember to distribute that negative. So negative 3 minus 2 is negative 5. 3j minus negative 5j is going to be 3j plus 5j, which gives me 8j. So I got that double negative there on that second term. For C, I have 3j times 1 minus 3j. This won't be FOIL because my first term doesn't have the two parts to it. So I'm just distributing. So I would have 3j minus 9j squared. Again, j squared is -1, so I'll have a double negative there. And then we always want to make sure that we put our answer in rectangular form. So I'm going to switch the order, and it's going to be 9 plus 3j. For our last one, we have division, so 3 plus 4j over 5j. We'll multiply top and bottom by the conjugate, which remember is -5j. So again, I don't have to FOIL, I'm just distributing. So if I distribute my -5j, I'd have -15j minus 20j squared. And again, j squared is -1. So I end up with 20 minus 15j for my numerator. My denominator is going to be a squared, which is 0, plus b squared. So it's just b squared, which is 25. So I end up with 20 minus 15j over 25. But that can be simplified, right? Each of my terms is a multiple of 5. So I'm going to cancel a 5 across each of my terms. And I'm left with 4 minus 3j over 5. Okay, so we've got this addition and subtraction. It's just combining like terms. Again, with subtraction, make sure you distribute that negative sign. Multiplication, it's the same way we would do it with polynomials. So it's usually foiling because we usually have a real and imaginary part for both of them. If not, then it's just distribution like we did in C. And then for division, multiply top and bottom by the conjugate of the denominator. So lastly, we're going to look at a really nice application that involves imaginary numbers. People always say, well, if they're imaginary, why do we need them? They're called imaginary. They do exist, and here is a really nice case of where they come into play. Whenever we have alternating current circuits, the values are represented by imaginary numbers. So we have the following formula, V equals ZI, where V is the voltage in volts, Z is the impedance in ohms, and I is the current in amperes. So V equals ZI. And given the following values, find the missing one. So for our first case, Z, the the impedance, is 3 plus 4j, and I, the current, is 2 plus 7j. And we want to find V. So since V equals ZI, this becomes a multiplication problem. So 3 plus 4j times 2 plus 7j. Right, we FOIL that out. Oops. So we get 6, 21j, 8j, 28j squared. Adding up our j's, we get 29j, 28j squared. Remember that is -28. So 6 minus 28 gives me my -22. So the voltage is -22 plus 29j. What if we know the voltage? So V is 5 plus 5j, and Z, the impedance, is 2 minus 4j, and we want to find I, the current. So we need to take our equation V equals ZI and solve for I. So we're going to divide both sides by Z. So we get that I is V over Z, and this becomes a division problem. So 5 plus 5j divided by 2 minus 4j, V over Z. We're going to multiply both the top and bottom by the conjugate of the bottom, which is Z, so 2 plus 4j. The top, again, we're going to FOIL it, so 5 times 2, 5 times 4j, 5j times 2, 5j times 4j gives us 20j squared, which again is -20. The bottom is again a squared plus b squared, so 2 squared is 4, -4 squared is 16, so we get 4 plus 16 on the bottom. We will combine like terms, so we get the 4 plus 16 is 20 on the denominator. The numerator, 10 minus 20 gives me -10, 20j plus 10j gives me 30j, and you always want to simplify. So we will cancel the common factor of 10 there, and then I'll distribute. So negative 1 over 2 gives me negative 0.5 for the real part. 3 over 2 gives me 1.5j for the imaginary half. Okay, so make sure you read the book and let me know if you have any questions. Thanks.